Okay, welcome to Dynamic Foundry Group. I'm Sandeep Kulkarni. Welcome you all to this webinar today on ductile iron with magnesium core wire, advantages and overview. I first of all welcome Mr. Sarthak sir and Shivaji Dagre, head of marketing from Sarthak Metals Ltd, who have ready to make this today's webinar. They have accepted our invitation and ready to make this webinar. So welcome both of you, Mr. Sarthak and Mr. Shivaji.
Yes, thank you.
Yeah. Just to introduce and start with Shivaji, I think he started his career under my guidance, and I think this is a proud moment for me because the person who has started his career with me as a lab assistant today heading the marketing department of one of the limited company, and very proud to see his growth over the period. So Shivaji, congratulations and well done. I'm very much proud of your
Thank you, sir.
and your efforts and your hard work. Regarding today's webinar, I must say it is an technology which is coming up in the era of last maybe 3 or 4 years. Earlier, we all know that we are using a very well-known or very popular technology of we called as a sandwich method. So apart from that sandwich method, we know there are few other methods like converter method or mold treatment method or any other on any few more methods which have been used in ancient time. But this particular technology of core wire has overcome last 3 4 years very becoming very popular, and people are trying to use it frequently. So there are many questions among the foundrymen about this technology. What are the benefits? How it works? What are uh, the changes in the sandwich method and this technology, and how we can get benefits out of it? So all these questions are there in the mind of foundrymen. So we thought this is the right way and the right time to take this topic to the public and to the foundry, and that is why we have conducted this webinar. So to understand the benefits and the overview of this technology, we have today Mr. Shivaji Dagre and Mr. Sarthak from Sarthak Metals Limited. So without taking much of time, I hand over the platform to Shivaji. Please carry on the presentation.
Yeah, thank you, sir. Yeah, hi, good evening, all. Before starting the webinar, I would like to thanks Sandeep Kulkarni, sir, and thanks to all ladies and gentlemen, foundry professional and experts are present here. Also, is thanks to Dynamic Foundry Group for giving this opportunity. Okay, and we welcome to all of you to our webinar, Unleashing the Power of Magnesium Wire Injection in Ductile Iron Manufacturing, its Advantages and Overview. I am happy to have you all here today as we explore this topic together. As you know, metal production is a cornerstone of numerous industries like automotive, aerospace, and construction and beyond. So the quality of and performance of the metal play pivotal role in these industries, driving innovations and progress. Today, we are diving into the world of magnesium wire injection, the technique which holds immense potential for enhancing the properties of the metal and elevating their performance to the new heights. So, before going to the PPT, just 1 minute, I will share it. Is it visible?
Yes, only you can go to the slideshow.
Yeah, yeah.
Yeah, perfect.
Yeah. Yeah. So my company name is Sarthak Metals Limited, and we are here for that webinar, a new technique of spheroidization through cold wire injection process for a ductile iron foundry. Yeah. That Sarthak Metals comes from the Desraj Bansal group. So we have three units or three companies that are like Sarthak Metals, Bansal Brothers, and Sarthak Energy. Our vision is we aspire to leaders for cutting edge solution for fine tuning of specialty alloys and castings. Especially Sarthak are doing code wire specialists. We are doing code wires for steel industries and foundry industries. Our turnover is around 450 crores per annum. It is an NSE listed, NSE BSE listed company, and we are exporting around 25 plus countries. Also, Bansal Brothers is world's largest manufacturer of ferro-titanium and magnesium alloys. Its turnover is around 400 crores per annum. Multiple state-of-art manufacturing facilities are here, like all induction furnaces and all lab setup is here for analysis of the all the elements and alloys. So this is our company information. So we go to direct for the wire that magnesium wire injection system. It is a schematic diagram, which in which you see here that magnesium wire injection machines and its operations. You can see here there are coils kept on the ground. These coils are for magnesium wire injection, magnesium wire, code wire, and inoculants core wire. So that code wire we are injecting or feeding into the molten metal with the help of the feeder. And this process is total atomized with the PLC logics. We are controlling all the parameters with the help of that logic. So it is just a diagram to understand how it works like that for that magnesium wire injection. Next. So Sarthak is already catering to all steel industries, aluminum industries, also foundry industries. In steel industries, we are for steel industries we are manufacturing around uh, uh, 2,000 to 2,000 metric tons code wires for steel industries like aluminum wires and code wires, calcium code wires, cafe code wires, case code wires, lot of wires which steel plants are using. Also for ductile and foundry, we are manufacturing specially all grades of ferrosilicon, magnesium core wires, and inoculants core wire. So we are going to the that ductile adder production. When we go for the ductile and production, we are using lot of metal, lot of methods to manufacture ductile ends. You know that open ladle sandwich process, tundish ladle process, pressure chambers in which your magnesium are using also converter process, then in mold process, and then core wire injection process. These are the processes are commonly used to manufacture ductile lamps. So what is a MG code wire? We go to the topic. Yeah. So magnesium code wire is a steel tube that contains granule magnesium or a mixture of magnesium and ferrosilicon magnesium alloy. Actually, it is a method to use in ductile iron production to introduce magnesium into the molten metals. The magnesium granules, magnesium alloy powder is encased in a steel or CRCA sheet, which forms a code wire, and that code wire we are feeding into the metal with a certain speed with the help of wire feeding machines. So also wire feeding machines comes with all logic programs which helps us to add exact required quantity of the wire into the melt. Also, it calculates exact quantity of magnesium wire which we require. It depends on your melt weight, sulfur of the base metal, and your desired magnesium. So by using empirical formula, it is automatically calculates the length of the wire and that wire to be fed into the molten metal. So cold wire looks like this. It is a CRC sheet. Inside that we fill the mixture of all magnesiums and all alloys. So why injection process is introduced? First of all, I want to tell you that magnesiums, you know that magnesium have low density, low solubility, low melting point, low boiling point, high vapor pressures, and great affinity to oxygen. So for that, when we are injecting to the this magnesium to the certain critical depth of the metal, then we are getting good recoveries. So that injection process are introduced in the foundry industries to manufacture ductile. Next, process requirements. What are the process requirements for that? You see in that pictures, the wire feeding system is wire feeders and then cold wire and major ladles. That unit the wire feeding system consists of sets of rolls which pulls the cold wire from the coil and inject into the melt through a guide pipe. Then the core wire is fed into the molten metal at a controlled speed and predetermined length. Core wire custom made Sarthak core wire to suit the foundry's process of spheroidization. It depends on the customer's requirement. Also, it depends the actually selection of the core wire. It depends upon the various parameters. What are the processes the customers are following? Also, what are the parameters, casting wall thicknesses? What are the requirements for the microstructures and physical properties? So that we are making customized code wire for each customers as per their requirements. So also ladle is very important. The gear ladle with dimension ratio of S is equal to 2.25D because we need some that uh, height in the ladle, um, self height in the ladle or freeboard around 500 to 450 to 500 mm for in the magnesium core wire injection because almost the wire comes with magnesium percentage minimum uh, 15 percentage above comes with above 15 percentage. So the reaction is vigorous. So to avoid this metal spillages, we are using the ladle as per your recommendation to avoid that spillage. So comparison between sandwich method and that your regular that core wire injection to see environmental impact in sandwich method. Lot of that magnesium smokes is coming. In white smokes is there. In injection method, we are actually my systems comes with the that ducting which we are connecting to the your fume extraction system. So there is a smoke is generated, but we are actually extracting and this system that treatment is fume free. So these benefits you will get in that environmental impact. Also flexibility is there. You can treat to metal plus minus 100 kg. Also desulfurization is possible. Slacks formation is less because we are not using punching. Temperature loss is minimum. So the activity is also favorable, uh, normal level. Capital investment is there compared to your sandwich method, and treatment cost is also favorable when comparing sandwich treatment. I will go to the next slide. So benefits of the magnesium core wax. The environmental impact. You know that harmful fume generation is controlled and minimized easily by connecting our feeder to fume extraction system. Secondly, environmental inside the plant is fume free. It gives clear visibility to foundry workers during operations. It avoids white MgO fume, which makes commonly smoke in winter seasons. Yeah. Therefore, we were facing a lot of problem of visibility in the night operations. So in that system, that we are taking care of your fumes. So visibility issue is not there. So it increases productivity in that case. As per pollution control board's requirements, that MgO fumes in foundry plants we are actually arresting them. So these um, pollution control boards sometimes penalizing some companies for that, so that penalty can be avoided. Then health and safety, safe use of reactive material, no direct touch to material because that all material in inside the coil which avoid direct handling of hazardous material. No direct contact of powder material inside the coil with ice. Coil outer layer is made up of from CRC strips, so material handling is better. Then metallurgical benefits, this is very important. Highly consistent and no risk of human error, guarantees of homogeneity, consistent recovery, lower loss in temperature, less lag generation. Also helps to achieve required nodulity, nodule counts, and physical properties like tensile hardness and pack. Higher productivity, can adjust residual mg as per casting average wall thickness to avoid shrinkages and other issues. Also TRE, lanthanum, low RE type of code wire can be added as per your casting requirement by using that double stand feeder and multiple stand feeder. Storage and handling, a clean and easy handling. Coil wrap with good quality of wrapping material which avoids moisture contacts with coil, which increases shelf life of the coil and avoid rusty and oxidation takes place. That coil cage can be handled with the crane or forklift during loading, unloading. No loss of material as it is in the coil form. We are displaying each coil number and dates on the coils, also on TC with invoicing details. So it helps to store the coils lot wise and helps to consume the coils as per FIFO. Then ease of operation, control and monitor quality. Injection parameter can be controlled and adjusted as every melt. Feeder comes with full automation and integration. So we can interface parameter like melt weight, temperature, initial sulfur with your PLC, which helps to calculate exact required length of the wire without manual interference. Feeder machine stops and give alarms if any failure of geared motor and proxy sensor. Pocoyoke with melt weight, injection temperature, bath sulfur can be done to avoid manual error. Heats data report generated after completion of each cycle and treatment. Less manpower required, manpower not required for weighing of CRCA punching and ferrosilicon magnesium alloys. Also for that adding the alloys into the ladle and poking the alloys. So manpower is also required, and this operation gives minimum fatigue to the workers which we are working in the heat in summer days for the magnesium treatments. So that is very important. So these are some area of foundry. You people know that when we are using that sandwich treatment and we are predetermine the additions of the magnesiums. Okay, so excess and less metal tap due to oscillating movement of the treatment ladder during the SG treatment. Sometimes what happened, immediate action can be taken, production divided to avoid heat loss, like they are checking initially MG, immediate, in spectro, and if it found okay, then they are pouring the metal like that. And second one is ladle pocket damage. Instant repairing is not possible. Sometimes there is a less chance to get well created second ladle available for operation. So that production department don't want to just lose the productions. So they are actually increasing sometimes MG alloys, punching, and continuing the production. So there is a lot of loss. Also, sometimes bad micro hits will happen. Then area of foundry, sometimes the ladle becomes more sluggish and preheated second ladle sometimes not available. So because of that, lot of failure of treatment due to MG fading. So sometimes foundry people is also adding higher MG additions, punchings, and continuing the processes. Whatever people's the foundry practices, a lot of companies they are adding excessive magnesiums, but not that keeping the record of that. So sometimes foundry store not getting correct that inventory. So sometimes in the records they are saying the 5 tons or 6 tons. It is an example are balanced, but actually physically they got around 2 tons, 3 tons. So what are the excess addition will that is not recorded by the production department. So there is a lot of issue regarding inventory. So why MG code wire? So conflictness of the mentioned plant mention pain points. So no control on inventory, found less stock compared to the documentary stock, increased MG addition not documented by the production department, data found for tracking of alloy consumption not matched, treatment failure because of bad ladle condition, final chemistry found deviation due to excess or less metal tap, foundry rejections like due to high addition of magnesium alloy resulting in more liquid slag generation, lower magnesium recovery, slag inclusion, carbide formation, cold, high hardness, and low hardness like that. Adding more cost by increasing MG alloy and punching, which affect treatment cost as well, BOM of your castings. So to eliminate above the all areas of pain, need magnesium code wire. So this is the schematic line diagram that our system actually we are interfacing our feeder with your spectro to get the readings of heat number and your bath sulfur and your we are also interfacing this with your pyrometer and weighing scale. So automatically that interfacing will take place and magnesium that calculation of the it calculates directly what required magnesium wire length. So there is no human interfacing is there. So no human of interfacing is there. So you this is a direct fully automated process. So applications, magnesium treatment of iron combined desulfurization, sterilization. Some people are doing duplexing, but nowadays no one is doing duplexing. So that is a different part. Topping up of the magnesium in the pouring furnace, combined sterilization and inoculation in the pouring ladle. The grades of magnesium code wire, lot of grades are coming that ferrosulfur magnesium 20%, ferrosulfur magnesium 40%, 50%, up to 100%. Actually, now we are working with only 3 to 4 grades that 20, 25, 40, 50 because that higher MG we are using where the sulfur bath sulfur range is higher. Also, some people are using rusty scraps. So their requirement of magnesium and calcium is higher. So we are using higher magnesium content ferrosulfur magnesium code wire. Wire diameter comes with 5, 9, 13 mm. Selection of the code wire. Selection of MG code wire depends on quantity of the liquid metal to be treated. MG code wire available with 9 mm and 13 mm diameter. It is commonly used in India nowadays. 9 mm MG we are using up to 1000 to 1000 to 1500 kg, and below 1500 kg we are below 1000 kg and above 1500 kg we are using 13 mm. It depends upon ladle dimensions and also the total pouring time of the castings. As per that, we are designing the core wire. This is a special example that magnesium core wire spec that magnesium 25 to plus minus 2%, ferrous at silicon 40 to 45%, calcium 1.5 to 2%. Excuse me. RE 1.5 to 2% and Fe balance. Wire shape round 9 mm and 9 plus minus 0.5 mm. Vertical flipping type. Powder density comes to 125 gram plus minus 10 gram. So sequence of the operations is very easy. Like your sandwich treatment, just tapping of the molten metal at predetermined temperature of known composition into the treatment ladle, then weighing of molten metal, set length of the core wire to be injected, set the wire speed, measure the temperature before injection, then magnesium wire injection takes place, then deslagging and metal we are handed over for the transfer or transfer to the pouring ladle and then pouring like that. So thank you. Yeah. Hello.
Thank you, Shivaji. It's a nice presentation. As we already discussed before, we'll have one more part of this
Yeah, definitely,
session
definitely.
next month where we are talking about the actual